All right. We have about 20 minutes to get through this lesson, which is plenty of time. How many of you found Riemann sums to be extremely tedious? Me. I'm right there with you, okay? But it's a step in our learning process as to how calculus works, okay? Now, if we're talking about area under a curve, are there some shapes that maybe you could find the area of without that big, long process? Yeah. Yes. You know how to find the area of squares and rectangles and trapezoids and circles and triangles, etc. So, if we don't have to do that long, tedious process of a Riemann sum, that would be great, wouldn't it? Okay? So, from here until the end of class, we're going to work with some more geometry-based integrals, and then also talk about how we can have negative or positive area. How many of you finished number 5? And you got an answer of 0, and that was really frustrating? Yeah. Okay, we're going to talk about why it's 0. Okay, but first let's talk about a couple of these. So write down the integral from 1 to 4 of 2 dx.
Is that the same as if you had, like how they were, like how it's like that? Is that the same as that? Like with the numbers?
Yeah, it's the same symbol. It's the integral symbol. Yep.
I just meant like if the numbers meant the same thing.
Yep. Okay, so these numbers, so this is saying, hey, find the area under this curve from 1 to 4. Well, 2. 2 is a horizontal line. So if I want to find the area under that horizontal line from 1 to 4, what is it? That is a 2 by 3 rectangle. The area is 6. I would draw the picture so you know how you got 2 times 3 equals 6. But that took a fraction of the time that it did to do number 4, 5, 4. Was 4 the first problem in your homework assignment? Yes. Okay, which was similar, right? It was, I guess it was X instead of a number. But fraction of the time. No calculus involved. Okay. My next example, the integral from -1 to 2 of x plus 2 dx. I would like you to write down our definite integral. Definite means I have numbers attached to the integral. Okay? Indefinite was just an integral with no numbers on it. So write down the definite integral and draw the picture of y equals x plus 2. Okay. Now, for this one, we could do a couple different things. Okay. When you look at this picture and we look from -1 to 2, you see a trapezoid. Other people might see. Okay, a rectangle and a triangle. I don't care what you see, as long as you use geometry to find it. Okay, if we break this up into that rectangle and triangle, we have a 3 by 3 triangle and a 1 by 3 rectangle. So we get an area of 7.5 or 15 halves, whichever you prefer. That's a times sagging a little bit. If you can imagine the picture and you can find geometric area, let's do it, okay? Okay. You need to recognize a semicircle when you see one. The square root of r squared minus x squared, you need to recognize as the top half of a circle. Okay? So in this case, I'm asking you for the area from 0 to 1 of the semicircle of radius 1. Graphically, the square root of 1 minus x squared is this that I have in red. But since I'm only going from 0 to 1, I'm asking you to find how much of that circle. It's a fourth of a full circle, right? So if I want that area, we have 1/4 pi r squared. Another popular equation to use geometry for, like let's say I gave you the integral from -1 to 3 of the absolute value of x dx. Could you use geometry to find me the answer to that problem? Okay. 2 triangles. Here is the absolute value of x, right? From -1 to 3, you would have 2 triangles. This great. Now, those of you who got all the way through the second problem of your homework, number 5, you had an area of 0. And you weren't quite sure if that was okay, but it was the right answer, 0. Okay. We can have positive and negative area. If we're talking about area under the curve, which is what a definite integral represents, then any function above the x-axis is going to have positive area. Any function below the x-axis will give you negative area. Okay? So in that problem, wasn't it like -1 to 1 of x cubed dx? Can you confirm that one? Yes? Okay. This is what x cubed looks like. -1 to 1 would be this area. Well, this is negative area. This is positive area. And with the symmetry, they cancel out. Those of you who haven't finished number 5, look forward to getting the answer of 0. Okay. What I would like you to do is on the next slide, I'm going to have a picture. I mean, it kind of looks like this, but there's going to be numbers on it. Go ahead and draw the picture with the numeric values with the A, B, C, and D. And we're going to talk about different integrals and what their numeric values would be. Okay, so take a minute and draw that up there. All right. So let's just say that this is function f. If I ask you for the integral from a to b of f of x dx, the integral from a to b of f of x dx, Alex, what would you tell me that equals? From a to b, okay. The integral from a to b of f of x is saying, what's the area under the curve from a to b? Okay. Now, what if I change this? Well, what if I say the integral from b to c of f of x dx? The integral from b to c. Brayden, what would you tell me? From b to c, 4? But since it's under the curve, we would call it, or since it's under the x-axis, we would say that that's a negative 4. Okay? If we're under the x-axis, we're going to call it negative area. All right. How about this? What would the integral from a to c of f of x dx equal? From a to c, what would that be? 1. We would add them together. 5 and negative 4, our area would be 1. Okay, I'm going to give you and your pod 2 minutes to find me the integral from negative 7 to 5 of f of x dx for this picture right here. You give me 2 minutes to find me the area under the curve from negative 7 to 5 for this function right here. Okay? 1, 2, 3, go. Work together. I just
We don't know the other one. Because we've seen it. So that's the time. Yeah, so from 2 to 5. But if you're looking at this time, it's actually just 2.5. Like the other time, so then I'd have to like actually.
this red area right here. What is it?
Yeah.
I think it would be -5 halves. There's 1, 2, 3, 4, 5. It's okay. It's 7 to 2, right? Okay, -5 halves. It has a height of 1, a base of 5, but it's under the x-axis. Okay? The green. Ethan, what do you have for the green? 2 pi? 1/2 pi r squared, and the radius is 2. So 1/2 pi r squared is 2 pi. All right. How about this blue area right here? Trent, what do you have for that?
15 fourths.
15 fourths. So you have a height of 3, a base of 5 halves. So 1/2 base times height is 15 fourths. I did write 15 times. Sorry about that. And then this area right here. Max, what's this? Positive? Negative? Okay. So then, one plus 2 pi. All right. Would be your area. Okay. The last thing we are going to talk about are some properties. Okay. So we are going to write down some properties of our definite integral. Okay. If I ask you to find the area from A to A of any curve, how much area is there from A to A? Okay, property number 1, the integral from A to A of f of x dx is 0. No matter what. There is no area from A to A. The integral from A to B is going to be opposite the integral from B to A. Basically, this is saying if you go to the left, your area is going to become opposite. The integral from B to A is opposite the integral from A to B. All right, and here's one that we used a couple slides ago, but we just never really talked about it officially. If you have the integral from A to C, well, and I know this is weird. This is how the book writes it, which is why I wrote it like this. The integral from A to C plus the integral from C to B, well, those are just two integrals back to back. So it's really just the integral from A to B. If C is in between, we can take those two integrals and just add them together. I don't know. If you want to do a to b plus b to c equals a to c, I have no problem with that. I think they try to keep the integral limits as a and b throughout all of these, which is why they did this. Now this is up to you whether you want to write these down. We wrote these other two down with our indefinite integrals, but they work the same with our definite integrals. If we are adding or subtracting inside of our integral, we could break it apart if we wanted to, okay? And if we have a constant inside of our integral, we can take it out front. We've already been working with that through our indefinite integrals, so I don't really think it's necessary for you to write this down, okay? Okay, we are going to do a 1 minute example. Are you ready? Okay. Take 10 seconds and write down the integral from 0 to 5 of f of x dx is 10. And the integral from 5 to 7 of f of x dx is 3. It's going to take you more time to write this down and think about the problem. Okay, so if I ask you for the integral from 0 to 7, the integral from 0 to 7, the integral from 0 to 5 is 10, plus the integral from 5 to 7 is 3, we would have 13. What about the integral from 5 to 0 of f of x dx? Negative 10. We have to make it opposite. Okay?
Y'all do this one.
Okay? How about the integral from 5 to 5? Everybody!
0.
What about 0 to 5 of 3 f of x dx? Oh man, I can't trick you. Okay, we made it! Yes, we made it. Thank you for your patience today. I know that these make for a long day. But guess what? You have 2 homework assignments due on Friday. So maybe do one tonight, one tomorrow night. Space it out. Don't wait till tomorrow night and do assignment and a half. Okay? So pretend that this is the end of 4th hour. And what would you do after 4th